Hello everyone. Today we are learning about how the files are stored on a disk using a different method. First one is the continuous allocation. Let's look at the picture. On the left we see a disk made up of small parts are called blocks from block 0 to 31. Some blocks are shaded, that means they are already used by the files. The empty ones are still free. On the right, there is a table showing a list of files. It tells us the file name, starting block of the file, and how many blocks it takes up. It's called the length. For example, the file count starts at the block 0 and uses 2 blocks. So, it takes block 0 and block 1. The file mail starts at the block 19 and uses 6 blocks from 19 to 24. And the file list uses the blocks 28 to 31. 4 blocks in total. Now, here is the main idea. Contiguous means next to each other. So, in this method, every file is stored in one straight line. All its blocks are together, side by side. This makes it fast and easy to read the file. But there is a small problem. Over time, when the files are deleted or added, empty spaces may appear between used blocks. These small spaces might not be useful for new files. That is called fragmentation. Next, a file storage method called linked allocation. It's how an operating system stores files on a disk. Imagine the disk as a long line of blocks numbered from 0 to 31. In our picture, some blocks like 9, 16 and 25 used by a file named Jeep. Here is the interesting part. The Jeep file starts at the block 9. Inside the block 9, there is a small arrow pointing to block 16. This means the next part of the file is stored in block 16. Block 16 also has an arrow pointing to the block 25. The block 25 is the last block. It has no arrow, so the file ends there. This is why we call it linked allocation, because all the file blocks are linked together using a pointers like a chain. The blocks are not next to each other. They can be anywhere on the disk. Each block except the last one has a pointer to the next block. The directory only needs to know the start and end blocks of the file. The advantage of using the linked allocation method is there is no need for blocks to be in a row. It saves the space. The file can grow easily by just adding another block on the chain. The problem by using this method is you have to follow the chain because you cannot jump to middle of the file directly. If a pointer breaks, the part of the file may get lost. So, linked allocation is flexible and space saving, but it is not the best for quick access. Finally, let's understand the file storage method called indexed allocation. It is used by the operating system to store the file on a disk. Imagine our disk has blocks numbered from 0 to 31. Let's take an example of a file named Jeep. This file is not stored in one place. Instead, its parts are scattered across the disk. So, how does the system keep track of all those parts? That's where indexed allocation comes in. Here's how it works. The directory says that the zip file uses block 19 as its indexed block. This index block does not hold actual file data. Instead, it contains a list of block numbers like a table of content. In this example, block 19 lists these blocks 9, 16, 1, 10, 25. These are the actual data blocks that make up the zip file. This means the operating system can directly jump to any part of the file by checking the index block. If we want the third part of the file, we just check the third entry in the block 19. No need to go block by block. The advantage of using the indexed allocation method is we can quickly get to any part of the file since it supports the fast random access. Files can be stored in any available blocks. So there is no external fragmentation is here. We can able to add new block numbers to the index block. It is easy to grow a file. But the disadvantage of using this indexed allocation is each file needs its own index block, even for the small files. If your file is very large, one index block might not be enough. In that case, more complex indexing is needed. So, indexed allocation is organized, efficient, and fast, especially when accessing files in the random order. I hope this video helpful to understand the file allocation methods. Thank you.